Hello, my name is Coco Renault, and today we're going to be talking about specific heat. By definition, specific heat is the amount of energy per unit mass required to raise the temperature of an object by 1 degree Celsius. That may sound like a lot to process, but it's more simple than it sounds. Essentially, specific heat defines how easy it is to heat something up. This concept is important in many different aspects of chemistry, but it's mostly applied to the transfer of energy between objects. This energy will always flow to where it is the most in balance with the objects around it. So imagine if you have one cold object and one warm object. When these objects are placed in contact, the energy will always flow away from the warm object and into the cold object. This can be seen in action in the experiment that I'm about to conduct, where I will place an object at approximately 100 degrees Celsius into water that is at room temperature. We're going to examine the temperature change and use that to calculate the amount of energy that was transferred. The metal is in boiling water that is at 100 degrees Celsius. So now that is a value that we can use to subtract from to find out the temperature change from the metal. Alright, now I'm going to put the temperature into Celsius. Alright, and the temperature is rising, and it has stopped rising at about 26 degrees Celsius. So that results in a temperature change of approximately 5.9 degrees for the water, which is inevitably a lot less than the temperature change of the metal object, which went from approximately 100 degrees to 26 degrees. If the specific heat of the water and the metal were the same, we would expect the temperature of the water to be between the metal and the water's starting temperatures. The temperature of the water did not increase a lot because of water's high specific heat, which is caused by strong hydrogen bonds between molecules. Although the same amount of energy was lost by the metal and was gained by the water's temperature didn't change as much as the metal because of its high specific heat value, which explains that it takes a much higher amount of energy to raise the mass of water the same amount of temperature. Now we're going to input our starting and final temperatures into the specific heat formula to calculate how much energy was transferred between our metal object and our mug. Now to calculate the energy transferred between the water and the metal, we are going to use the specific heat formula, which is Q equals mc delta T. So in this equation, Q stands for energy, which can be in joules or kilojoules. M stands for mass, which is usually in grams. C stands for specific heat, which is in joules per grams degrees Celsius. And delta T stands for the the temperature change. So we're going to solve this for our experiment by doing Q equals 188 grams. This is the mass of water that was in our mug. And then we're going to multiply this by 4.18 joules per grams degrees Celsius, which is the specific heat of water. We're then going to multiply that by 5.9 degrees Celsius. This is the temperature change as the water started at 20.1 and it went all the way up to 26 degrees. Alright, now when we multiply this out, let's see what we get. 188 times 4.18 times 5.9. That's going to give us 4,636.45. And then with sig figs, we're going to round it to 3 decimal points because that is how many sig figs were in our temperature value. So Q equals 4,640 joules. And that is the amount of energy that was transferred between our metal object and our mug water. Thank you.